think. Okay, there we go. This should be good enough. Let's use that one. Yep. Okay. Now let me start a VS Code. VS Code. Okay, so I think the encoder decoder model was okay. I need to make a decoder only later, but I am thinking of reworking on this whole part of the model. Okay, let me change the screen. There we go. Okay. Yep. And we are back to coding once again after a very long time. There we go. It's working. You saw nothing in the chat. Yeah, I saw everything variant. I saw every single thing. Anyway, so I was like trying this out, but it's not that good because the model I have gotten does not work properly. So if I like do this, I don't know if it's gonna be able to run on stream or not. Okay, there we go. Unfortunately, he died at a very young age. And it says joy. I don't know why it's saying joy. I need to fix this somehow. So what I'm thinking is either the dataset is not correct or we need to like re-code like the whole thing because from what I can tell, the model is not that good. Where's the model.py? SRC, the model.py. I was trying to follow the research paper for this thing. Let me download the research paper first. I guess we are gonna have to delete all of this first. Maybe not that. Output model data and configs. Okay. Okay, let's remove that. Let's remove this. Remove that. Remove that. That and that. Okay. Let's delete all these. And we also delete this. And we delete that. Tokenizer needs to be gone. You know what? I'm just gonna delete like the whole folder. Okay, so now let's start on working with an ANN model architecture. First of all, let me download the research paper so I can open it in this. Wait, do I have it downloaded or not? Let me see. Downloads, ANN. Is this it? No, this is CNN. I have not downloaded the ANN research paper. But there we go. Right, security check, verification, download full text PDF. There we go. Introduction to ANN.pdf. Move this right here. What do you mean I can't open install? Install. I want to be able to read PDF in VS Code. Okay, there we go. And now we can read this PDF while we try to make it. What are artificial neural networks? Artificial neural networks are artificial adaptive systems that are inspired by functioning process of human brain. They are systems that are able to modify their internal structure relation to a function objective. They are particularly suited for solving problems of non-linear type being rules gone. Okay, okay. The base element of ANN are nodes, also called processing element PE. Wait, is the but in the I think in the latest research paper this has been replaced by positional encoding. We will have to see about that. In the connection, each node has its own input from which it receives communication from the other node. and or from the environment in its own output, which it communicates with the other nodes. The environment finally reaches the node as function F, to which it can transform its own global input to output. Each connection has a character size. Okay. Okay. So this is an artificial neuron. So these are the input and dendrite, axon, output. Okay. So these are the input DIMMs, these are the hidden DIMMs, and these are the output DIMMs. Neurons can be organized in any topological manner. One, two, three blocks. Okay. Depending on quality or amount of input data, the most common ANN is topology, certain PE come called feed forward topology. Okay. So we are working with a classic MLP or a feed forward network, I think. The most common in composed so far feed forward topology. A certain number of PE combine an input layer normally depending on amount of input variables. The information is forwarded to one or more hidden layers working within the ANN. The output layer as the last element in this structure provides the result. The output layer contains only one PE. Oh my goodness, what the heck is this PE? I keep on forgetting. I keep on like mixing it with positional encoding. Processing element. Okay, let me make a um what is it called? Terms.md markdown script. Okay, these are the terms used in this paper. Number one, PE. It stands for processing element, not positional encoding. Okay, wait, is that working? Why am I not seeing a completion? Oh, it's turned off for markdown scripts. Okay, I see, I see. What are artificial neural networks? Nervous system. Oh, yeah, I read that. Okay. Neurons can be organized in any topological manner. 1D, 2D layer, 3D layer, more dimensional ND layer. Okay. Depending on quality on input data, the most common ANN composed is so-called feed-forward topology, feed-forward network. That is basically it. The information is forwarded to one or more hidden layers working within the ANN. The output layer, as the last element of this structure, provides the result. The output layer contains only one processing element, whether the result is binary value or single number. Architecture of neural network is backpropagation. Backpropagation. What the heck is backpropagation? Now I don't know that. I need to research about it also. In the neighborhood, the way these connections are made might offer a difference between the subtypes of neural networks. Each of these connections has so-called weight, which modifies the input of the output value. These connection weights is determined during the training process. This functionality is the base for ANN learning capability. Therefore, it is important to understand there are no classification. Okay, so we cannot use classification for this. Oh, okay. For different things. Neural Works, professional by Neural Wire Incorporation, Cambridge, Pennsylvania, USA. ANNs are high pattern recognition like abilities which are needed for pattern recognition decision making. Okay. This means that if they receive certain data in one phase, ANN focus on certain rules, but if they eh, receive new and different data, ANN will adjust their rules accordingly, integrating the old data which is new, and they can do this without any external instructions. Okay. A continuous updating of data under their management creates a dynamic bank whose rules automatically refined by ANN as problem question. Okay, okay. When n variable, which it is also data and m variables, which differs from first and about to difficulty only cause gathering data, access whether. Okay, so we need to predict m on the basis of n. When m variable occurs subsequently in time to n variables, the problem is described as prediction problem. When m variables depend on some sort of static or dynamic factor, the problem is described as one of recognition and or discrimination or extraction of fundamental traits. Okay, okay. Database random selection, then yeah, that's just the training cycle. I think there was also an HRM. Oh, what I think, Variant backpropagation is calculus 3-4 stuff, not that difficult. Well, I need to know how to apply it. Wait, backpropagation. Wait, was it that one where you constantly find the slope? That one. X3 minus x2 upon. Oh, no, wait. What was the formula? I forgot. Why is. Oh, wait. Why is Voltomex plus E? Okay, so if we do that, m should equal to y upon x. Oh, yeah. Y3 minus y2 upon x3 minus x2 minus x2 minus. No, I mean y2 minus y1 upon x2 minus x1, and whole of that is divided by x3 minus x1. I think that was the formula. Wait, let me just open up Paint. Here we go. We are currently in Paint. My handwriting is pretty bad, and along with that, we are currently on. Hmm. Okay. So is it like this formula? Um. Oh my goodness. It. Okay. I can just do this. Y cube minus y square, and all of that is being divided by x cube minus x square. No, it's okay. So we have that, and you are saying it's based upon something else. And what the heck am I talking about? Sorry for you don't divide anything. Oh, okay. Don't save. Let me switch this over back to VS Code. It's just derivatives. Ah, I see. Wait, okay. Yeah. In theory, number of type of problem that can be dealt with NN is limitless as methodology is broadly applicable to problem. Okay. Wait. So can I use this to teach my model how to do maths? So like if I put in 1 plus 1 into the model, will it generate the output? Wait. First, let's make a data maker. Okay. Because from what I can tell, I can input anything and it will give me a certain output. But the input size needs to be defined on beforehand. Okay. What is a good data set for ANN though? I don't know exactly. Yeah, don't worry about it. Okay, so let's do something like this. Maybe like we can do some sort of price prediction with this. So we need to make a data for a price. So first of all, import pandas as PD, import. Do we need NumPy? I'm gonna skip on NumPy for now. Okay, so let's create a sample data. So let's say we are gonna create it for 1,000 rows. For I in range 1,000 df. No, we don't want to do that. We want to do hmm, let's see. What can we do? Okay, let's first decide some variables. Um, cost is equal to fuel plus toll plus time plus labor. Okay, let's make a sample data like that. import random, and we all okay. We can do an autocomplete on this, and then remove this part. Df is that okay, and we move this one to the first slot. Okay, now then we have all of this. So then, can we use these four values to predict what the cost is going to be? Hmm. Okay, let's try it out. Wait, what is this? LOC. What is this function? Oh, okay. Okay. So once we do that, we then are gonna save that data frame. Okay. And let's also import TQDM. Import from TQDM, import TQDM. I quite like the TQDM module. So I can do TQDM range and that. Okay, there we go. Nice. And it should work. The data has been saved. Okay. So this is just randomly generated data. And now let's do a like data spread thingy. So if I just copy all of this and do def generate synthetic data, then move all of this up here, move all of this away. Okay. So now that our data has been generated, we are gonna do def analyze data. Let's analyze it first. If name is equal to main, analyze data. Although I want to see it not like that, I want to see like it plotted out. Okay. Hmm. Now then, you can do plt.figure. Wait, what? No, we don't want to do that. We want to make a scatter. plt dot scatter. Oh, yeah, no, that's not gonna work. How do I plot multiple things on the same thing? Let me take a look on chatgpt.com. How can I plot 5? Okay, let's see this. I want to see a scatter, like maybe like a heat map should be good enough. Wait, let me ask it. Okay, let me just ask ChatGPT how to do this one. Hmm. Okay, here we go. We have the scatter plot part. Can just paste this right here. Okay, and let's analyze it. And there we go. Okay. Okay, the cost goes quite high, and then all these values are down here. Okay. But we kind of need um, a good spread of these. So yeah, okay. Hmm. Can we modify this to generate a bit more realistic data? Okay. Okay, so this should generate a bit more realistic data from what I can see. Let's copy this and let's paste it here. This is purely so I can generate a bit more realistic data. Import numpy as np. There we go. Not mp, np. Okay. Okay. Okay, so let's generate the synthetic data, then we can analyze it. Yeah, that looks a bit more realistic. Okay, so that will generate the data and save it. Now that our data maker has been done, okay, let's make a model.py, import torch.nn as nn, class ann, nn dot module. Then we are gonna do def underscore init under underscore self. That should be enough. Do we need a hidden size? We could do the hidden size. Hidden size, output size. Okay. We are gonna remove this because we don't exactly need that. And we are gonna do a sequential model first. Should we do a sequential? Or I think we should do that in a forward pass. Yeah, we should do that in a forward pass. We could do self dot linear one is equal to that thingy, and let's make a config dot py import torch in a model. Then we can do um, device is equal to CUDA L. Okay, input size is equal to how many inputs are we gonna give it? One, two, three, and four inputs. Okay, so we have four input size. Then we have hidden size 8 and output size is equal to 1. Okay, 1, maybe like since we are predicting a number, hmm, wait, let me ask ChatGPT. If I'm making an ANN model for this dataset, how many DIMMs would I need for hidden and output DIMM? As input DIMM will be 4, I assume. Okay, let's see. Okay, yep. Okay, so that is correct. We need to do this 64. I guess since we are doing that. Oh wait, how many can I do? It's saying 16 or 32 should be enough. Okay, so we are gonna go with 16 layers for that. And is there anything else we need? Okay, we are not gonna touch that right now. I'm gonna do from config import everything. Then we don't even need these. Okay, dot layer one should equal to nn dot linear input size hidden size. Okay, this does not look good. We need to apply relu twice, I think. Okay, and since we are not making this a sequential model, oh yeah, we need to make it ourselves. Okay, 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 okay. Def forward self comma x return out. Okay, that should be it. Unless I do 16, keeps on dividing. Okay, 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 okay. But that should be good since we are not using a sequential model. We need to do this manually. Should we normalize it? Yeah, let's add a normalization. Okay, so we get the input, then we pass it to first layer, then we normalize it, then we do that. And then should we do this or not? That's the output layer. No. Okay. So let's see how is this model. Don't make any changes, just give advice. Oh wait, my bad. I need to change this to nn.module. What is the comment? Okay. For your data set, one can sample, start with layer 32, if not getting okay, okay. Okay, and what kind of model have they made using, okay, that was a TensorFlow model. Okay, 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 okay. Model is equal to net, but that's just the model initialization. Let's try to make a trainer.py from tqdm, import tqdm, from model import ann, model is equal to ann dot to device pura. Now we're gonna do model is equal to ann, import config dot to device config dot device. Let's try to do this again because I kind of messed that up. Adam optimizer model parameter allows learning rate. Okay. Okay. I don't know how to make a trainer though. That's the main thing. Okay, let's put in LR right here. LR is equal to batch is equal to 32. Output size should equal to 1. Okay. Let's move this that for that. Training parameters, num epoch. Okay, and what did we need? We need weight decay. Yeah, no, let's not use weight decay. We are gonna make this a simple model. Okay. Okay, let me try to make this a bit better. What the hell variant? What have you sent me? What the heck is this? What the hell is this? Sir, you know this is illegal. Oh, you are just showing this one. I saw this. Oh, this is back propagation. Huh. Variant. You have just copied that thing from what was the channel name? If you have derivative for each, then calculate the step size that is usually in gradient descent. Yeah, I need to do this on a pen and paper. Did you just copy that thing from StatQuest? How the hell are you playing War Thunder, doing this, and being on stream all the things at the same time? How is that even possible? Okay, make okay. We don't need the learning rate right there. We can replace it with LR and now epoch, and also we replace LR is equal to LR. Num epoch is equal to dot num epoch. I'm an AI. Yeah, no, you are. Okay, I'm not gonna. There's a goddamn. Okay, and with that should be good enough. Okay, complete this trainer for me, please. Wait, what do I need to do? What did it say again? I don't have a. Okay. I get it. Let's copy this part. This is the whole damn trainer. We can just remove all of this because I don't want that all, to be honest. And let's use TQDM right here. Oh wait, we need to do TQDM. Description is equal to training progress. Can we add something else? Oh wait, no, that's gonna show it. Okay. Just like Barnacle. Hey, you calling in for me? Just lead us into the light. With the temperature, baby, tell me one more beautiful life. One touch and I ignite. Like a starship speeding into the light. Up in the infinite light. Tell me one more beautiful lie. One touch and I ignite. Okay, let's do that. And then we need to do import pandas as PD. Move that down there. And then we need to do df is equal to pd.read from data.csv. Wait, how do we implement the batch size reader? Anyways, this should work hopefully. Let's try to run it without blowing things up if we can. Please work. Why is the loss so big? What the hell? What the hell you mean? What the hell you belly? Okay. We need even more data. So what I'm gonna do is go back up here and we're gonna set this to not 10K. Let's do 100K. 100K lines of data should be good enough, right? Yeah, we need to wait a minute. I think you didn't get that model right. Yeah, we need to wait for a bit. We are processing data at 1000 lines per second. It's going to take a minute to prepare the data. I mean, the data is falsely generated. Loss is percentage is not. No, wait. I don't think that is in percentage. Is it? Is it though? I don't think so. Should I have normalized it first? Like, because this is just raw data. So first we need to do the data pre-processing where your data is normalized. No, but having in raw data is better. Yeah, but we can't normalize this data because if we normalize this data, then in the real situation, it would not be good. And I think normalization only works if, say, you have like separate values. So let's say you have kilometer and meter in the same part of the table. Then you need to convert all of that to meter or either kilometer. But since we are working with theoretical data, we are assuming that all of the values are of the same category. So let's say we are taking all the values in liters, meters, and other things. Yeah, the output is wrong. I definitely know that. Okay, let me just improve this trainer. To be honest, I don't know how to make a trainer. I know how to make the other things though. Uh-huh. Why are we using that? Why are we using that? Huh? Use the train test split from torch. I don't want to use sklearn. Sklearn is for stupid people. Yeah, there we go. Okay, there we go. We are gonna plug this into the trainer right there. Okay, then we are gonna do, oh, yep. Okay, then we need to replace the training function. So this is the training function. Okay, we are gonna have to replace this whole part with that. Split data XY. Okay, up. Yeah, maybe that was way too much. We will have to see what happens. Okay, let's load the data first. Then we do this part. Is there a for loop in here somewhere? Nope, there's not a for loop. Train ratio, we are gonna do 90s, 80s to 20 training ratio. Okay, that should be good. Let's try to do this again. Yeah, no, the model is broken. We are using wrong type of data set. The data is wrong. Okay, our data set is wrong. It's quite unpredictable, if you know what I mean. Okay, let's remove this. It's not the data set. I mean, we are generating random data. This is all literally like random values. How am I outputting the values? The values are being returned like this. So we have our layers right here, layer 1, layer 2. Wait, do I need to add a hidden layer? I think I should have added a hidden layer. Okay. Self dot hidden. Okay. Okay, let's do this like 2 or 3 times. Okay, that many times should be good enough. Yeah. Okay, let's try that again, hopefully. Yeah, no, there's definitely something wrong. Okay, I need to make the data myself, I guess. First of all, let's reduce this to size of 10 for a very small data set. It should be made instantly. There we go. Okay, now if I run the trainer, it should work. Yeah, the loss, there's definitely something wrong with the loss calculation. What is the loss function even doing? Okay, let me switch over to my other ID that I have. It's called anti-gravity. It's by Google and it's quite good. It's better than Microsoft's Visual Studio Code, anti-gravity. I was trying to make a chain of thought model. Ignore that part. Okay, models. Oh, there we go. Okay, now it's gonna help us to um, fix this code. So anti-gravity is also quite good. This is a perfect example for me to show it to you guys. So see, I executed that output, okay, and why is the output so out of range? And right now I'm using Gemini 3 Pro. From what I'm hoping is that it's because of the training data being bad, because otherwise it would not make any sense. Should I try to increase the output layer though? You know what, in the meantime that it's thinking, oh wait, it's working now. Okay. In the meantime, I guess we can try to change this to 10. Let's see what happens if the output layer is 10. Perhaps because of this. Nope. Okay. It's taking a bit longer than usual right now. Oh yeah. I've exhausted all of the resources. Okay, how long is this even gonna take? The only problem with these agentic models is that too many people are using them. So it runs into lags such like this. Okay, how long is it gonna take? Let's switch to Gemini Pro Low. Try again. Oh, yep, it's working, and we will see the magic that it can do. So it has analyzed it, and now it's going to be generating the solution to that and also modifying my files. This is quite like a useful tool for me at least because I have to work on things alone and do some research, make other things, and it helps out quite a lot. But in the long run, I won't say that like you should rely on it, and that's why we are working on our own. I don't think that training loss is working properly, at least the loss calculation function. And we need to still keep on waiting for this to process. Working. Okay. In the meantime that it's working, I guess we can try to look and figure out what's going on. Is it because of the MSC loss? Wait, wait. Why aren't we using the cross entropy? Oh, okay, it's because of that. But we are doing by prediction. Okay. Okay, it's gonna and go over every single file that we have, and then it's gonna work its thingy, and hopefully it's gonna work. I have to end the stream in like 10 minutes though. Anyways, yeah, I gotta end the stream by now. I have to go. Mm. Oh yeah, we need to. Yeah, I knew it. We need to do something. What did it do in this file now? What the heck did you do in this file? Okay, so we need to normalize our data set from what I can see. Because from what I can tell, some data is in thousand and some data is in hundred. So it's messing up there at that point, I think. So we either need to put everything into the hundreds or everything into the thousands. Or we can put it between 0 and 1, which is more suitable. Let's see its implementation plan. Yep. We needed to add normalization. Hey, variant, you were right. The trainer is correct, the data is wrong. We need to fix the data. Anyway, so this agent is gonna do it for us in the trainer.py file. I mean, we could just modify our data maker. I have a bottle of water and I'm not afraid to use it. Like, can you please do your job? Thank you. In the meantime, let me take a look at 305. That seems promising. Okay, let's see how it is now. Okay, so the train loss is decreasing and the validation loss is also decreasing from what I can see. We don't need that many epochs. Okay. Yeah, we just needed to calculate the mean. Yeah, don't worry, variant we have fixed it. We just needed to normalize the data set. Okay. Now we can try to make a larger batch of data. Let's make it 10,000 lines of data. This should process like quite quickly. Yep. And there it goes. That's a good data spread. Okay. Now let's train the model on it. Okay, yep. And that is still running. Okay. Now then let's do. Wait, why is torch in red color? We should have imported it. Yep, that works. Import torch. Okay, there we go. Yeah, I know. You forgot it's still VSC. No, it's not VSC, it's anti-gravity. It's not VSC. Oh, I need to save the model first. Save model.pt. And then we run this and 1457.91. Okay. Fuel was 500, toll was 100, time was 60. What was the formula that we were using? Cost is equal to, okay. So we can check if our cost was actually on point or not. Okay. I mean, it's pretty close. It is pretty close. Should we increase the size of the data set? Let's set this to 20K. That should be good enough, right? Yeah. And since the model is overfitting quite a lot, from what I can see, we can set this to 32 as well. Okay. Let's run the trainer again. A company lost $300 because of you. Oh, well, too bad for them. For the validation loss decreased till some point and then it started to increase again. Okay. Yeah, no, we kinda need to add like an early stopping to this. Hmm. Okay. Okay, there we go. We can go back to anti-gravity, apply engine, and then paste in that. And this should work for it. It might know the optimal way to do it. Just ask AI for that one. Yeah. Okay. We have triggered validation loss at epoch number 71. So the best one should be around 61. Right there. Or that one, I think. Let's try to reduce this a bit, I guess. Okay. What about now? We are kind of close, but not that close. I mean, we don't want to do back propagation. Right now, we are making an ANN, artificial neural network, though. Okay, so let's look into our config. Since that's not working, let's try to look at our model.py really quick. Hmm, Let me see. This is my simple ANN model for the problem. Oh, wait, I can't use the same normalization layer. Oh, okay. Oh, I was using the same normalization layer, apparently. So it's saying I should do this instead. Because apparently the values are stored in the batch normalization thingy. Oh, backpropagation is a technique for a neural network. Okay. Let's see if this improves the model a bit or not. Yeah, wait, that improved the model quite a lot, actually. Okay, and how does it perform now? I mean, it's bad. I think it's overfitting from what I can see. Let's reduce the size of the model. We don't need that anymore. Okay, four hidden states good enough. And one of the reasons I think that's happening is because the model has too many layers. So we kind of need to reduce on the layer part. Okay, yeah, we need to remove some layers from this model. Where did that go? Okay, let's use only one hidden layer. We don't want four of these. There we go. Let's train the model again. But map propagation is naturally finds the best way to get lowest cost. So yeah, no, it can't be default. Oh, you are using linear regression. Yeah, we are using linear layers. We are using nn dot linear, not nn dot backprop or something like that. Okay, now why the heck that happened? Let's put this to 32. I mean 16. Hey, that actually worked quite well. So I need to increase the model size, it seems like. Okay, let's set this to 32. I had a shit professor. I don't know how linear is naturally handled, not gonna lie. Oh, okay. I mean, we don't really need to do that because PyTorch is doing that for us. Okay. 32 layers mm, broke it, it seems like. Let's do 64 layers. Yeah, that should be good enough. So every time we are changing the config, we need to train our model again, and after that, we need to run it the inference. Yeah, so the optimal value was at 16 layers. Ah, okay, I will try to look into that later. Yeah, this is the closest that we are gonna get to it. I feel like at least. Okay. Yeah, I'm gonna end the stream now. It was fun. A bit of gaming, then a bit of coding, and it's almost been 4 hours. Okay, so I'm gonna be going now. Bye, guys. Have a great day. Thank you for joining, and I will see you guys later. I need to put that song back in.